2.
Hi, my name is Nick Shipman, and this is interactive advanced concept presentation for Fireproof balloon. I've got my balloon filled with air, got my balloon filled with water, and today I'm going to be conducting an experiment to see which substance, the water or the air, will pop a balloon with a flame next to it. So, starting off with my balloon with air, got my flame. I think that knows how this is going to go, so everyone protect your ears. Oh, that was really quick. Louie, don't eat that. And then I've got my balloon filled with water with my flame. And this should not, I'm going to hold it closer, but this really should not pop. So we'll do it for a few more seconds here. It's getting nice and black underneath. Bring it close to the camera. Look at that. Not gonna happen. Okay, so let's talk about why this isn't going to happen. So let me just set this down. So water and air. So water is a pretty good conductor of heat, meaning it's going to absorb the heat, and then air is going to be much less conductive. Like I said, water is going to absorb the heat energy, and then for air, the heat transfer is much slower, meaning that the balloon is going to pop once the flame gets to it. So the water won't allow the latex to get to its flash point. So I wrote down the heat capacity of water and air. So water is 4.184 joules per gram, and the heat capacity of air is 1.012 grams per joule. And both water and air are actually both less conductive than solids. So it goes, solids are greater than water, greater than gases in terms of the distance of atoms from one another. So the greater the distance of atoms, the less conductive they will be. So also with our law of conservation of energy, we know that energy is not created or destroyed, it's only converted from one form to another. So the air isn't like some superconductor or something where it just allows the balloon to pop because it wants to pop, and then the water isn't some like shield that just doesn't allow the balloon to pop. The energy from the flame is being absorbed by the water. It's being distributed throughout the water. So so it's helping to lower the temperature of the balloon. So I actually wrote down this equation, which is the thermal energy equation. So it's Q equals M times C times the change in temperature. So I weighed out my balloon. I actually have 860 grams of water in there, and multiplying that by our heat, or by our water constant, or not constant, but heat capacity is 4.184 grams, joules per gram. And then I multiplied that, assuming that the water itself has to get to about 100 degrees before the balloon will actually pop, or maybe you start reaching like a vapor temperature where it actually expands and pops. That's probably something different. But 100 degrees minus 21.2 is what Celsius is what I measured my water at. And so that actually gets us to 283,541 joules per gram, and so making that number a little bit smaller, a little bit easier to say, 283 kilojoules. So that's how much energy it would require for me, from my flame, to get the water, 860 grams of water, to boiling, which would then potentially burst my balloon. So in conclusion, water has a higher heat capacity than air and will prevent the balloon from popping due to the amount of energy required to heat it up. And that is my presentation.